Okay, hi everyone, and welcome back to the Comptia Security Plus course. Networking protocols and threats. The threats are many: malicious attacks such as denial of service attacks, man-in-the-middle attacks, replay attacks, and session hijacking can all be devastating to individual computers and entire networks. But once you have built a decent knowledge of ports and protocols, you can use that intelligence to better protect your servers and network against a plethora of attacks you will face. One thing to remember is that there are always new network attacks being developed, and many that currently exist but are unknown. Therefore, this chapter is incomplete in the sense that once it is written, it is out of date. Keep this in mind, and remember to always keep on top of your security bulletins, common vulnerabilities and exposures, CVEs, and security updates, ports and protocols. I can't stress enough how important it is to secure a host's ports and protocols. They are the doorways into an operating system. Think about it. An open doorway is a plain and simple invitation for disaster, and that disaster could be caused by one of many different types of malicious network attacks. The security administrator must be ever vigilant in monitoring, auditing, and implementing updated defense mechanisms to combat malicious attacks. Understanding ports and protocols is the first step in this endeavor. Port ranges: inbound versus outbound, and common ports. Although some readers of this book will be familiar with the ports used by the network adapter and the operating system, a review of them is necessary because they play a big role in securing hosts and will most definitely appear on the exam in some way, shape or form. Ports act as a logical communication endpoint for computers. Each protocol uses a specific port. For example, HTTP uses port 80 by default. These ports are ultimately controlled on the transport layer of the OSI model by protocols such as the Transmission Control Protocol (TCP) and User Datagram Protocol (UDP). TCP is used for guaranteed connection-oriented sessions such as the initial connection to a web page, and UDP is used for connectionless sessions such as the streaming of data. There are 65,536 ports altogether, numbering between 65,535. The ports are divided into categories as shown in Table 7.1. 0, 1, 0, 2, 3 well-known ports. This range defines commonly used protocols. For example, HTTP uses port 80. They are designated by IANA, Internet Assigned Numbers Authority, which is operated by ICANN, Internet Corporation for Assigned Names and Numbers. 1049, 49, 151 registered ports. Ports are used by vendors for proprietary applications. These must be registered with IANA. For example, Microsoft registered port 3389 for use with Remote Desktop Protocol, RDP, also known as Remote Desktop Connection. 4915269 dynamic and private ports. These ports can be used by applications but cannot be registered by vendors. You need to understand the difference between inbound and outbound ports as described in the following 2 bullet as illustrated in Figure 7.1. Inbound ports. Used when another computer wants to connect to a service or application running on your computer. Servers primarily use inbound ports so that they can accept incoming connections and serve data. For example, 7.1, the server with the IP address 66.102.1.100 has an inbound port 80 open to accept incoming web page requests. Outbound ports used when your computer wants to connect to a service or application running on another computer. Client computers primarily use outbound ports that are assigned dynamically by the operating system. For example, Figure 7.1, the client computer with the IP address 172.30.250.3 has outbound port 3266 open to make a web page request to the server. The IP address of the computer and that port is its sending or receiving are combined together to form a network socket address. An example of this will be 66.102.1.100/:80. This is illustrated by the IP address of the server in figure 17 and the inbound port number accepting the connection from the client computer. Notice that when they are written, the two are separated by a colon. The IP address precedes the colon with the port number follows it. Figure 7.2 illustrates a few more examples of this within a Windows client computer. It shows some of the results of netstat an command after FTP www and mail connections were made by the client to two separate servers. The first call out in figure 7.2 is the initial FTP connection. This happens when the user first connects to an FTP server with FTP client software. Notice that the local computer has the IP address 10.254.254.205 and uses the dynamically assigned outbound port 55768 to connect to the FTP server. The remote computer, on the other hand, has the IP address 216.97.236.245 and uses inbound port 21, known as a command port, to accept the connection. Keep in mind that this is only the initial connection and login to the FTP server. Subsequent data connections are normally done on the server via dynamically assigned ports. For example, the second call out FTP data connection occurred when the client downloaded a file. It is a separate session in which the client used the dynamically assigned port 55769. In reality, this isn't quite dynamic anymore. The client operating system is simply selecting the next port number available. Afterward, a subsequent and concurrent download would probably use port 55770. The server, on the other hand, used the dynamically assigned port number 31290. Many FTP servers randomly select a different inbound port to use for each connection to increase security. However, some active FTP connections still use the original port 20 for data connections, which is not as secure, not only because it is well known, but also because it is static. To secure FTP communications, consider using software that enables dynamically assigned ports during data transfers. For example, Pure FTP, https www.pureftp.org, project Pure FTPD on the server side, and FileZilla, https filezilla.project.org on the client side. If your server enables it, you can also consider IPv6 connections and as always, be sure to use strong complex passwords. I don't mean sonic broken record. The third call out in figure 7.2 shows a HTTP connection. Note that this is being made to a different server, 208.80.152.118, and uses port 80. And finally, the fourth call out shows a POP3 connection that was previously made to the same server as the FTP connection, but note that the port number reflects POP3. It shows the port number 110. Always be mindful of securing connections. If you are making an encrypted POP3 connection using SSL TLS then the port number used would most likely be port 995. These are just a few examples of many that occur between clients and servers all the time. Try making some connections to various servers from your client computer and view those sessions in the command line. Aside from servers, ports also become particularly important on router firewall devices. These devices operate on the implicit deny concept, which means they deny all traffic unless a rule is made to open the port associated with the type of traffic desired to be let through. You need to scan your servers, routers and firewall devices to discern which ports are open. This can be done with an aforementioned netstack command with an application such as nmap, https nmap.org, or with an online scanner from a website. The most effective way is with an actual scanning application. Afterwards, unnecessary ports should be closed. This can be done in various ways. Within scanning the operating system GUI, for example, in Windows, open the Computer Management Console, then go to Services and Application. Services, right-click the appropriate services and select Properties. From here, the service can be stopped and disabled. Within the CLI, for example, a service can be stopped in Windows by using the netstop command or with the sudo stop service command in Linux. Within a firewall, simply setting the firewall normally closes and shields all ports by default, but you might have a service that was used previously on a server, and therefore a rule might have been created on the firewall to enable traffic on the port. Within the firewall, software rule can be deleted, disabled, modified as needed. In general, network firewalls protect all computers on the network. So this is where you should normally go to close particular ports. Unnecessary ports also include ports associated with non-essential protocols. For example, TFTP port 69 is usually considered a non-essential protocol, as in Finger port 79. Telnet port 23 is insecure and as such is always considered non-essential. However, the list of non-essential protocols differs from one organization to the next. As always, rescan the host to make sure that the ports are indeed closed, then make the necessary changes and documentation. Depending on company policy, you might need to follow change management procedures before making modifications to ports and services. Protocols that can cause anxiety on the exam. Unfortunately, a lot of the protocols look similar, behave similarly, and can be downright confusing. Let's discuss a few of the more difficult ones to try and dispel some of the confusion. We start with FTP and its derivatives. You know about the FTP protocol and what it does. You probably also know that FTP can be inherently insecure. There are several ways to make FTP sessions more secure. We mentioned previously that you can use FTP software that randomizes which ports are selected to transfer each file. You can also select passive mode instead of active mode. More FTP clients default to passive. The difference in that in passive mode, the server is required to open ports for incoming traffic, and in active mode, both the server and client ports open. Then you could use an FTP protocol that is secured through encryption. Two examples are Secure FTP SFTP and FTP Secure FTPS. SFTP through encryption. Two examples are Secure SFTP and FTP Secure. SFTP uses SSH port 22 to make connections to other systems. Because of this, it is also known as SSH FTP. However, FTP works with SSL or TLS, and implicit mode it uses port 990. Control port and 989 data port to make sure connections and send data respectively. FTPS can work in two modes, explicit mode and previously mentioned implicit mode. In explicit mode, the FTPS client must explicitly request security from an FTP server and then mutually agree on the type of encryption to be used. In implicit mode, there is no negotiation and the client is expected to already know the type of encryption used by the server. In general, implicit mode is considered to be more secure than explicit mode. So in summary, regular FTP uses port 21 as the control port by default, and possibly port 20 to do data transfer, or more likely it uses random ports for data transfers. It sorry now. If the software allows it, SFTP uses port 22, FTP uses port 990 to make connections, and port 989 to transfer data by default. TFTP, which is not really secure, uses port 69. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.